Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem shortest common supersequence. So it is a medium level question and the company tags are Microsoft, but the same question has been asked by Apple, Bloomberg and Google as well. Alright, and the topic tags are strings, dynamic programming, data structures and algorithms. So what is the question? So, and before we start, this is the problem of the day on Geeks for Geeks. All right. So what is the question? So question states that given two strings x and y of lengths m and n respectively, find the length of the smallest string which has both x and y as its subsequences. All right. So you need to find the length of the smallest string. That is very important. I'm stressing on that part, smallest string. So there are various strings that are possible that have x and y as its subsequence, but you need to return the smallest among them. And you need not return the string. It's fine if you can return the length of that particular string. All right. So x and y can have both uppercase and lowercase letters. And these are some of the examples that's been given. We'll see that in brief on the notepad. And the expected time complexity is O of n into m. So let us assume length of the x substring is m and length of y substring is n. So in that case, O of mn. Same is the case with auxiliary space. They're expecting us to solve in O of mn. But we have solved that in O of n itself. All right. So we are using the space complexity of like auxiliary space of O of n. So here they have asked us to use O of mn, but we are doing it in O of n itself. And time complexity remains the same in their code as well, like in their expectation as well as in our code. So to be honest, both of these works, and I need not do like I need not optimize this auxiliary space, to be honest, but I still did it just to educate you people on this particular method. And the constraints are like the length of the strings can go up to 100. That's the one of the reason that we can actually use O of n square or O of n into m happily here, both in space and time. All right. So this is the question. Now let us go through the examples. So this is the example that's been given. First example. So x is equal to a b c d and y equal to, so capital Y equal to x y c d. All right. And y is the answer. Well, in this case 6, because the answer, like a smallest substring that has both of these as its subsequences are as its subsequence is a b x y c d. Why? So you can find a b and c d. So x is found. All right, x is found. What about capital Y? You could find xy, and you can find cd and cd. All right. So y is also found. So you have both x and y as a subsequences. Right. So if we just erase this part, so we could find. So this is the x, a, b, and c, d. All right, this is x, and x, y, and c, d. This is y. All right, so you can find both x and y as its subsequences. So that is the reason this is the smallest thing possible. Now what are the other possibilities? You can even add a, you can even add d, you can even add e, you can even add f, you can even add a, z. Lot of possibilities are there, lot of strings are there that have both x and y as its subsequences, but they have clearly mentioned to return the shortest one. So what do you mean by shortest one? Shortest one in the sense you do not need any extra characters apart from the characters that are present in x and y. All right, so we'll frame that approach, but right as of now, just understand why a b x y c d is the answer. I mean, why length is 6 is the answer. All right, that is the question. So why length 6 is the answer. Now come to this particular question. X is equal to e f g h. All right, and y equal to j g h i. So what is the output for this? Like answer, the smallest thing that has both of these are the subsequences is e j f g h i, isn't it? So you can find e f g e f g h, all these four, e f g h. So this is x, and what about the other thing? We have j g f y. So j g h i. So right, all these things. So j g h i. So this is basically nothing but y. So you could find both x and y as the subsequences in that particular string e j f g h i. And what is the length of this? This length is 6. So that is the reason output is 6. All right. So this is the smallest string possible. Is there any other string possible that is much more smallest and cover all these characters? No, it's not possible. All right. So that is the reason. This is the smallest substring and that smallest string, and that's the reason we are returning 6 as the answer. All right, now how do we frame the approach for this? So this becomes a pretty easy problem. If you know a concept. So what is the concept? We'll name the data. Let us first understand how are we going to come to a conclusion that we are going to use that particular concept. So let us take this particular example itself, the very first example. So x is equal to abcd and y equal to xycd. Remember, they are asking us to find out the length of the smallest string possible, such that they have all the characters. All right. So all the characters of x and y. So how many characters are there in x and y? Totally 8 characters are there, right? 8 characters are there. Total 8 characters are there. But are there any repeating characters? Yes, we have some repeating characters. We have CD common to both of them. So let us subtract that thing, because we only need x as a subsequence. We only need y as a subsequence. We do not want a string to have x plus y. We need, that is not the thing. The thing is, our string must have x as its subsequence, y as its subsequence. And for that reason, you need not follow this particular rule. It's enough if you find all the characters of x. If it's enough if you find all the characters of y. That's more than enough. All right. So now I'll be subtracting this particular 2. Why? Because CD is being repeated for twice. So I'll subtract it. So 8 minus 2, that is actually equal to 6, and that is the answer, isn't it? Come to this particular second example. X is equal to EFGH and y equal to JGHI. So how many total characters are there? 4 plus 4 is equal to 8. And are there any repeating characters? Yes, we have GH in GH being repeated for twice in both x and y. X we have GH, in y also we have GH. So we'll just subtract GH for once, because we only need it for once. That's more than enough. So minus 2 equal to 6. So that's the reason 6 is the answer. So what can you find? You are actually adding the length of x and length of y, and you're subtracting the length of that part that is common to both of them. All right, that is common to both of them. So let us assume there are 4 characters that are common in x and y. So you'll be subtracting 4 by in the sum of x length and y length. All right, so that's how you'll be doing it. Very pretty evident. But how do we find it? How do we find the length of the common sequence? So length of the common sequence, the longest common subsequence is what you'll be aiming for, right? It's not like, let us assume in this case, instead of EFGH, just erase this part. So instead of EFGH, let us assume I have EFGH I J Z A B, and in this case I have GH Z and B. So what is the longest subsequence that is common to both of them? We have GZJB here, and similarly we have GZJB here, right? We have this wait, I'll be writing it properly. GZJB. All right. Why am I not able to write? So GH. All right. GH. This part, right? GHJB. All right, this is common to both of them. So what is the length of this? 4. So what is the output for this particular case? So EFGH4 4 9. So this length is 9 x string, and length of the y string is 5, and you'll be subtracting 4 from it. So in that case, 9 plus 5 14, and 4, that is 10. So your output will be 10. All right. So GJB is repeating for twice in common, like it is common to both x and y. So we'll be subtracting it, and rest of the characters will be there. All right, rest of the characters will be there. Instead of GHJB putting it for twice, we'll only be putting it for once. So that is the reason we'll be subtracting 4. All right, I hope you people understood. So how do we find this? This is basically nothing but the common thing, that's the largest common thing, is basically nothing but LCS, isn't it? Longest common subsequence. I hope 90% of the people who are watching this video already know LCS, because LCS is a standard concept. Whatever the stage you are at, once you have covered that particular DP thing, or at least strings thing, you would have gone through this particular concept, longest common subsequence. All right, so I'm not explaining it further again, but I'm doing a space optimization method that I'll explain, but I'm not going to explain LCS in a clear-cut way, because there are plenty of good videos on YouTube already that have explained that have good explanation of LCS much better than me. So I don't think it's better to invest time on that. So I hope you people understood. So what is the final answer for this particular question? It's like length of x plus length of y minus LCS of x and y. All right, so if you just do it, you'll be getting the final answer. This is the final answer. So final answer is basically nothing but length of this x string plus length of the y string, and minus longest common subsequence, like this length. All right, this is the length. So length of LCS of x and y, length of LCS of x and y. All right, I hope you people understood. Now let us go through the code. So this is the tabulation method for LCS. I hope everyone of you might be knowing this. So we'll be taking a 2D vector, and you'll be finding it. DP of ij is basically nothing but 1 plus DP of I minus 1 j minus 1 if both of the corresponding characters of x and y are matching. If not, we'll be taking the maximum of left and right top. Okay, left and top, isn't it? You'll be taking the maximum of left and top, and we will be putting that value in the DP of ij. Finally, you'll be getting that maximum value, like the longest common subsequence value, in DP of m and n, and you'll be subtracting it from the sum of lengths of individual strings x and y. So this is the final answer. But how are we going to space optimize this? Remember, like you can clearly see this. DP of ij is only dependent upon DP of I minus 1, j minus 1. All right, and either it's dependent upon db of I j minus 1 and dp of I minus 1 j. All right, so it's like only depending upon your current position and your previous position, isn't it? It's only dependent upon your current vector and your previous vector, like dp of I, and dp of I minus 1. That's it. They are not depending upon dp of I minus 2 or minus 3 or I minus n or anything. It's only dependent upon dp of I and dp of I minus 1. So instead of maintaining a whole 2D vector, it's better if you only maintain two vectors, that is previous and current. So previous means that the previous values that you have already computed, and current means that current values that you're going to compute. So that's what I've done. So replace, how do you do it in a very easy manner? dp of I minus 1 in the sense previous, right? dp of I minus I in the sense current. So dp of I means you are at the present position, you are at, like evaluating for the current row. So you'll be replacing dp of I by cur and dp of I minus 1 by previous. So that's what I've done. So take vector in previous n plus 1 and current n plus 1, because n plus 1, the reason being we are going up to n values, we are going up to like the length of the second string. So that is the reason vector in previous of n plus 1 and current of n plus 1. So starting from int I equal to 1, j equal to 1, you'll be checking the corresponding characters. If they are same, that means you'll be taking the value from your previous and add 1 to it, isn't it? So initially dp of ij. So what we had is, so initially if both of the corresponding characters match, then dp of ij is basically nothing but 1 plus dp of I minus 1 j minus 1, isn't it? So what I'm trying to tell you is replace dp of I by current, then that becomes current of j, then 1 plus dp of I minus 1 as previous, isn't it? Because dp is what the values that we are storing. So dp of I minus 1 in the sense previous values, previously stored values. So 1 plus previous of j minus 1. So that's what I've written. And else, if not match, what are you going to do? So you'll be taking the maximum of dp of ij is actually equal to maximum of your left, that is dp of I j minus 1, and your top, that is dp of I minus 1 j. So replace the things again accordingly. So dp of I is basically current. So this is also current. So current of j equal to maximum of current of j minus 1. And how do you do this? dp of I minus 1 is previous. So previous of j. All right. So that's what I've written here. Current of j equal to max of current of j minus 1, comma previous of j. And after every iteration, replace your equate your previous vector to current vector, because for your next part, for your next iteration, or for your next evaluation, your current will be the previous, isn't it? Once you're going to the next step, your current would be the previous for it, for that particular next current tabulation. So for that is the reason this updation is very required. And finally, once you're done with all of the other thing, all of the computations, now LCS is basically nothing but current of n, isn't it? Current of n or previous of n, both of them works because you're equating previous to current. So both of them works, and finally you'll be subtracting that from the addition of the lengths of the x and y. All right, I hope you people understood. Very evident, very easy approach. If you have like good command on LCS, then this is a very easy question. To be honest, nothing much to think. So it's just a basic sense, because they clearly asked us to return the smallest string possible, and we know smallest string can be done by adding all the characters and subtracting that characters that are common to both of them, isn't it? So both of them can be found by LCS, longest common subsequence. That's what we have done. So this is a space optimized approach. Like the space complexity here is only O of n. Here the space complexity is O of m into n. So this works completely fine, even if it goes up to 10 power 5 or 10 power 6, in 10 power 4, because you also need to worry about your time complexity, right? Because you're solving your time complexity. That the time complexity is O of m into n, TC, in both of the cases. All right. So here as well it is O of m into n. So you need to make a note of it. All right. I hope you people understood. Let us even like it submits, like there is some internet issue. So for your reference, codes in Java, Python and C++ are there in the description. Go through them, and please let me know if there are any doubts through the comment section. So thank you for watching. Stay tuned.